Okay, Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. So today we would be discussing another problems. Okay, this is an interesting problem from 2023 pretest from Institute Teknologi Bandung. So this is a pretest that has been given to ITB student, ITB student in the 2023 to some sort of this is the initial assessment to assess basically their cognitive and academics knowledge regarding uh, fundamental sciences such as math, physics, chemistry. But in this video, we would be discussing particularly the mathematics part. Okay, so let's start by the number one. So let me rephrase the questions in English. So maybe it would be better if I'm not wearing the if I'm not wearing my glasses because my glasses reflects the light from the computer. Well, okay. The question state as follow. So, for example, we have S of n. So S of n represents the summations of a term of the term on of a term in a arithmetics in a geometric progression. So this is a1, a2, a3 is basically a geometric progressions, and SNs is basically denotes or represents the summations of those terms of those geometric terms. Now we know that the ratio of the geometric progressions is equal to half, and the first term is equal to 3. The question asks for the smallest, what is the smallest value of n that fulfill these conditions? This is the conditions that was being asked by the problems. So we have to basically uh, find the smallest value of n such as this uh, inequality be true. Okay, we would start by dissecting to the problems first. Well, basically identifying the information that was being given from the that we could infer from the problem. So we knew that the a1, the first term, is equal to 3. The ratio of it, yeah, is equal to a half, and this is an important informations to analyze geometric progressions, because basically if we want to find the n term of a certain geometric progressions, so a of n is representing the n term of a geometric progressions. It would be a to the power a times r to the power of n minus 1. This is the formula for finding the n terms of geometric progressions. And we knew that the condition that was being asked is this one. Okay, is this one. Okay, is this one. Okay, so S of n, we knew the formula. The basic formula of it is Sn is equal to a to the times 1 minus r to the power of n divided by 1 minus r, which you know the r and a itself represent this one and this one, a1 and r. Yeah. So later we could replace the a and r with this, but for the sakes of our discussions, at the initial we will not inserting the value first, we will be inserting it later. Okay, and the n is basically showing the n terms of the progressions of the summations. Okay, and denote that the n the n that we choose must be element in bigger n. So basically what it says what it says that the n that we choose must be natural numbers natural numbers, which is 1 2 3 4 5 and continue. Okay, okay, yeah, let's get that. Okay, well, basically we could find, because we know the value of A and we know the value of R, we could find the value of N, the smallest N, the smallest possible N that we could choose from the statement, itself. Okay, so if we were to uh, dissect, insert the formula of Sn to the formula, we could do that, and this would be like this. And for the formula of S of n minus 1, well, simply we could change the formula from n, well, right, the initial formula is n, right? So we could replace the n with n minus 1, okay? And we could do a little bit of algebra here. We could dissect this into, we could separate this to r to the power of n times r to the power of minus 1. And we could do some distribution property. We could apply some distribution property here because a is uh, exists in these two terms. Yes. So we could uh, move out the A to the front. Okay. Well, that might be not the best word to describe it, but I don't know what the phrase for it. I'll be looking for the terms later. Okay, after this video. So basically, we could using the distribution property, because the A is exists in these two terms, so we could move it out to the to out. We can move it out. Okay, so A times these terms. Okay, the term that it left, right? Okay. Uh, and now we could do some simple algebra again. This is my minus 1 plus to the, if we distribute the minus, so this would be minus 1 plus r to the power of n times r to the power of minus 1. And this one would cancel with this one, right? Because this is basically minus 1, this is 1, 1 minus 1 is 0, then this term cancels out. What we would left with is this term. Okay. Now again, the same goes with the A. I'm sorry. The same phenomenon, I would say, happens with the r to the power of n, because r to the power of n is exists in these two terms. Yeah, these terms and these terms. So basically we could move it out to the front, and what it will left is these terms in the insides, r to the power of minus 1, right? Now, well, this term is simple enough, so we could insert the value of a and r to the inequalities. Don't forget this is 0.1. Okay, the r, don't forget, 1 r is a half, a 1, or basically a is equal to 3. Uh, r is a half, and r to the power of minus 1 is basically 1 over r, which is 1 over a half, which is 2. So 2 minus 1 is 1. So we could ignore this term then, because this is equal to 1. Okay, so what would left would be these terms, and we could insert it. The a is 3, r is a half, and 1 minus r is half, so 1 minus half and is a half. And therefore, because this is the tricky part, or maybe not the tricky exactly, but sometimes people forget about this. Okay, because the a half, because these terms, this exponent, yeah, so this is a half, this is an exponent with the basis is a half, right? And this is exactly an exponent too, with the basis a half, and the power is 1, right? Because well, it would be just the same, right? The basically the basis of the uh, exponent, both exponent has a same basis. Therefore, we could apply the rule, which if we have a to the power of n divided by a to the power of n, this would be a to the power of r minus n. So with this would be uh, a half to the power of n minus 1. Okay, and we could also divide it both side with 3, or basically multiply both side with 1 minus 3. So this would cancel out, and this would be 1 over 10 divided by 1 over 3, and basically 1 over 30, and this the term. Now, from this, we could, using our logics, we have to find the minimum value of the n. Okay, we have to find the minimum value of the n. Okay, what is the minimum value? Well, if you think it clearly, if you try to think it, okay, why the question asks for the minimum? Yeah, because, yeah, uh, why not the maximum? Okay, we will find out about it later. Okay, so basically we have to find the value of n such as this inequality is true. Okay, so if I wrote a half to the power of 5, basically, okay, are this is are this inequality is true, because this is basically 1 over 32 divided by 1 over 30, which is bigger. Okay, which is bigger, this one, right? This one. Don't be fooled. Okay, don't be fooled by the numbers of the divisor. Okay, because no, don't forget that the bigger the divisor, then the smaller the whole value is. Okay, so this equation is true. Okay, what if I chose 1 to the power of 4, for example? This would be 1 over 16, and this equation will not longer be true. Yeah, because 1 over 16 is bigger than 1 over 30. What if I chose 1 over 8? 1 over 8, 1 over, what if I replace it with 3? 1 over 8. Well, this would be larger, right? What we have to find is the condition when it was less, yeah, than 1 over 30. Okay, so what is the minimum of it then? What is the minimum? What if I choose 1 over 7? This is would be 1 over 60. I think this would be 1 over 1 over 128, and this equation will be still true then, right? If I set it to 6, 1 over 64, 1 over 30, this is true, right? What if I choose 5? Well, this is still true. Why is this is 5? What if I choose 4? 1 over 16. Well, then we have find our smallest value, 5, but not yet done. Okay? It means that the the what is that called? I forgot what it's called. The the power have to be 5 in order to be its the smallest value, right? So this term have to be equal to 5, so that it was the smallest value possible. So therefore this have to be equal to 5 for it to be the minimum case. This is the minimum case. Therefore the n must be equal to 6. So this is the analogy or the logics behind this. Okay, we have experiments with various value of power, and we knew that 5 is the maximum limits. But because is 5 is the overall, I would say, overall power of the exponent, right? So 5 is the minimum value, and this have to equal to n minus 1, right? So we could do some simplification. 5 is equal to n minus 1, and n equal to 6. This is the minimum. Okay, I hope that explains everything. Thank you for watching until the end. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.